When you have a project of this magnitude, 14,500 jobs, nearly $5 billion in investment.
Imagine looking up and seeing what looks like a flying manta ray. No nose, no tail, just a sleek, silent shadow gliding across the sky. It's not science fiction, it's real, and it might be the future of military aviation. In 2023, the U.S. Air Force placed a $235 million bet on a radical design called JetZero, a blended wing-body aircraft so different, it throws out everything we know about how planes are supposed to look. Headlines called it revolutionary. But here's the twist. This isn't innovation, it's resurrection. Because this idea, it's nearly 100 years old, and the last time engineers tried it, it almost worked. Almost. The roots of the blended wing body, or BWB, stretch back nearly a century. In the 1920s and 30s, aviation pioneers like Jack Northrop believed aircraft should ditch the traditional tube-and-wing layout. By embedding the payload within the wing itself, you could dramatically reduce drag and improve lift. A dream of pure aerodynamic efficiency. In 1946, Northrop rolled out the YB-35 and later the YB-49, all-wing bombers designed for long-range missions. Their designs were stunning but unstable. With no onboard computers to correct their pitch and yaw, these aircraft were a pilot's nightmare in bad weather. One test flight ended in tragedy, and the Air Force shelved the project. The flying wing disappeared into history, or so it seemed. Fast forward to the 1990s, and the idea resurfaces in a new form. Now called the blended wing body, or BWB, this iteration had one major advantage. Technology had caught up. NASA and Boeing began collaborating on a joint research project to evaluate the concept's potential for commercial aviation. Their X-48 program, started in 2000, used small-scale models with fly-by-wire systems and modern composites. Early wind tunnel tests were promising, so were the numbers. A well-designed BWB could cut fuel use by 20 to 30%, reduce noise around airports, and use fewer structural parts. And because the central fuselage is flattened and wide, it opens up entirely new design possibilities inside. Not just rows of seats, but clusters, lounges, even bunk areas, in theory. But theory and reality rarely align in aviation. When Boeing seriously examined the concept as a next-generation passenger airliner, several issues grounded it fast. The biggest red flag? Passenger certification. Because the cabin is so wide and shallow, fitting it with emergency exits and ensuring rapid evacuation became a logistical headache. Simulations showed that meeting the 90-second evacuation rule, the gold standard for airliner safety, would require an entirely new approach to interior layout and passenger flow. No one wanted to redesign every safety system from scratch. And then there's the comfort problem. Most passengers like windows. They like sitting close to aisles. In a BWB, only the middle seats can actually align with forward motion. The rest are sitting at weird angles or far from the exterior wall. That's fine for military or cargo. It's a hard sell for civilians paying $900 for a 12-hour flight. Even with fuel savings and reduced noise, airlines backed away. The public simply wasn't ready for an aircraft that looked so different and felt even stranger inside. Boeing quietly shelved its commercial BWB studies by the late 2000s and 10s. NASA scaled back funding, and for a while, the idea hovered in limbo, not dead, but dormant. Until JetZero came along. Rather than pushing for a commercial airliner, JetZero positioned the BWB as a solution to a different kind of challenge. The Air Force's need for longer range, more fuel-efficient aircraft, tankers, surveillance planes, or future cargo haulers. And in that space, where evacuation and comfort matter far less than volume and efficiency, the BWB could finally have its moment. For decades, engineers believed the blended wing body would change everything about commercial flight. It promised fuel savings, lower emissions, and quieter landings. And in technical trials, it backed those promises up. But despite NASA's optimism and Boeing's early investment, no BWB ever made it to commercial production. The reason? It wasn't the flying, it was everything else. Commercial airliners aren't just machines. They're subject to layers of regulation, customer behavior, and economic reality. And when the BWB met those forces, the dream began to fall apart, particularly emergency evacuation. The FAA's 90-second evacuation rule is strict. Every passenger must be able to exit the aircraft within 90 seconds using half of the available exits. For traditional tube and wing aircraft, that's relatively easy. Doors are spaced out along the fuselage, and everyone is near an aisle. But in a BWB, the cabin stretches wide and shallow. Some passengers would sit far from any exit, and the flat geometry complicates chute placement. Engineers floated creative solutions: multiple aisles, multi-level exits, even inflatable tunnels. But none of them fit cleanly within existing FAA frameworks. Getting a brand new cabin layout approved could take years of testing and millions in redesigns. That's not a risk most manufacturers want to take, especially when traditional aircraft are already profitable. Then there's passenger perception, something much harder to solve with engineering. People expect airplanes to feel a certain way. They want a window, a sense of direction, a quick walk to the bathroom. But inside a blended wing body, those expectations break down. Only passengers seated near the front edge of the wing would get windows. Others would sit in the middle of a vast flat space with no clear view outside. Some seats face slightly inward or outward. That's disorienting. And without a familiar tube-shaped cabin, the interior feels more like a movie theater than an airplane. There's also motion sensitivity. The farther from the aircraft's centerline you sit, the more you'll feel turbulence. In a BWB, that means some passengers experience a totally different ride than others. Harder to predict and harder to market. And then there's the timeline. Certifying a brand new passenger aircraft can take 8 to 12 years. And that's assuming nothing goes wrong. Airlines can't afford to gamble that much time and money on a concept that might struggle with public acceptance. Even if the BWB offered 20% fuel savings, that edge could disappear if travelers choose a more familiar aircraft. 1 or 2% fewer bookings can erase those gains. For airline executives balancing spreadsheets, certainty beats potential every time. That's why, despite glowing wind tunnel data and beautiful concept art, the BWB passenger jet faded into the background. Not because it couldn't fly, but because it couldn't sell. Then there's the issue of passenger psychology. People like what they know. Sitting inside a BWB doesn't feel like a plane. It feels like a conference room. No windows, no clear sense of direction. If you're seated near the center line, you may not see daylight the entire flight. If you're seated farther out, you'll feel more motion during turbulence. And forget about quick trips to the lavatory. You're navigating across a football field. Even if fuel savings reach 20% or more, airlines worry customers won't tolerate the unfamiliar. After all, a 1% drop in bookings wipes out efficiency gains. It's not just about aerodynamics, it's about perception. And finally, there's the cold math. Every new aircraft takes 8 to 12 years to certify for commercial service. That's before a single ticket is sold. In an era where sustainability and cost dominate airline strategy, few were willing to bet their future on a jet that couldn't guarantee FAA approval or passenger loyalty. So, the dream of a BWB airliner faded, not because the technology didn't work, but because airlines didn't want to risk what already did. The JetZero concept is more than a futuristic airframe. It's a quiet revolution in disguise. Because while much of the public still sees it as a radical passenger plane of the future, its real purpose is far more immediate and grounded. It's not just about reinventing how people fly, it's about redefining how missions are flown. JetZero has given the blended wing body what it always lacked: the right mission, the right partners, and the right moment. For nearly a century, the BWB was a solution waiting for a problem. It made perfect aerodynamic sense: lower drag, more lift, and increase fuel efficiency. But commercial aviation moved slowly. Passengers wanted windows, regulators wanted traditional exits, and airlines wanted low risk. The BWB didn't fit that model, but now the US military is asking a different question. How do we fly farther, stay airborne longer, and do more with every drop of fuel? In that context, the blended wing makes perfect sense. JetZero's aircraft doesn't need to carry 300 passengers. It doesn't need window seats or galleys. It doesn't need to pass FAA evacuation drills. What it needs is volume, range, and adaptability. And that's where the BWB shines. The Air Force sees the potential in roles like aerial refueling, long-endurance surveillance, and cargo delivery. Missions that require high fuel capacity, long flight durations, and large internal space. The BWB's thick central body holds more fuel than a conventional fuselage of the same size. It generates lift across the entire airframe, and its smooth design naturally reduces radar visibility. A bonus, even if stealth isn't the primary goal, but more importantly, it frees designers from the constraints of traditional aircraft. The interior can be optimized for fuel bladders, modular cargo, communications equipment, or future drone control stations. There's room for creativity, not just conformity. This isn't just a better plane, it's a platform, one that could evolve into multiple variants, uncrewed cargo haulers, hybrid electric transports, even low-cost intelligence and reconnaissance aircraft. And if the demonstrator proves successful, it could pave the way for a whole new category of military aviation, one where form follows function, not legacy. But maybe the most important shift is psychological. If the JetZero demonstrator works, if it flies well, refuels bombers, hauls cargo, and stays efficient, then it changes the conversation. Airlines might take another look. Cabin designers might find new layouts. Regulators might ask better questions. In time, the BWB could come full circle, not just in a hangar, but in the skies above us, carrying passengers after all. And even if that never happens, it doesn't matter. Because the real legacy of JetZero isn't about who boards the aircraft, it's about what takes off because of it. But if the skies finally embrace the blended wing body, what else might be possible once we let go of the old way of flying? Let us know what you think. Make sure to like this video and subscribe to our channel.